What I'm going to do in this video is work through the questions on quantitative chemistry you have in the back of your booklet. These are the past paper questions. One thing just to point out is you should have access to the actual mark scheme for this, which is on a separate document in the Google Classroom. But my thought is for some of the questions you might be getting stuck on, you might want them explained as well. So what I'd suggest is you can dip in and out of this video, fast forward, fast backwards, to get to the question you're stuck on, and hopefully with a wee bit of explanation, it'll make sense to you. But I'll just go from start to finish, starting with question 1. Question 1 tells you it's about relative atomic masses, formula masses and mole calculations. Part A is a definition. What do you understand by the relative atomic mass of an atom? So save myself writing it out, that is just straight out of your notes. Here's what you need for the 3 marks. Mass of an atom compared to that of a carbon-12 isotope, which is a mass of exactly 12. The wee bit of learning off, plonk it down, that gets you 3 marks straight away. With part B, it actually leads you through a mole calculation. I know when we looked at them, we normally use the table method. Now, oftentimes in the exam, they're not going to let you do that for the whole question. It's going to split up into 1 mark bits. Something I would say, a wee bit of exam technique, if you like using the table method, there is nothing stopping you doing the whole calculation start to finish at the bottom using a table and then just writing your answers in with your calculations at each step. So it's up to you. But if I just go through part by part, first thing I want you to do is to calculate the relative formula mass of barium sulfate within this equation. This is barium nitrate with sodium sulfate making barium sulfate plus sodium nitrate. Barium sulfate's this bit. It gives you the masses handily to speed things up for you. So in this one, it's going to be 137 plus 32 plus 16 times 4 gives you 233 as your answer. Part 2, same question but for barium nitrate. Barium nitrate has this formula, a barium and then 2 NO3 groups. So that becomes 137 plus 14 plus 3 16s all twice. Just carefully through multiplication there, should give the answer of 261. Part 3 leads you through a mole calculation. It wants you to work out the number of moles of barium nitrate in 13.05 grams of the compound. So if I remember that moles equals mass over RFM. Mass is in the question, 13.05. I just need to pick the correct RFM, being careful here. Moles of barium nitrate. So the RFM of barium nitrate I've just worked out in part 2, 261. So 13.05 over 261 gives me 0.05 moles. The final part of this question is here. Use your answer to B part 1 and B part 3. So give me a couple of hints here. To calculate the maximum mass of barium sulfate that can be obtained from 13.04 grams of barium nitrate. So it looks quite open-ended, but we've done a lot of the working out already. What I've worked out in part 3 is the 13.05 grams of barium nitrate is just 0.05 moles. From that 0.5 moles, and it gives me the equation, so it must be important, 0.05 moles of this must make a certain amount of barium sulfate. That involves using your ratio in the equation. Now in this case it's quite a simple ratio. 1 barium nitrate makes 1 barium sulfate. That therefore means that 0.05 moles of barium nitrate should make 0.05 moles of barium sulfate. Final part of the question, if I've got 0.05 moles of barium sulfate, I need to work out a maximum mass, just the mass of it, and I need to use another equation for that. Mass equals moles times RFM. Substitute in 0.05 moles. The RFM I've already worked out, that's why they're not giving me an extra mark for this. It's 233 from part 1. The answer therefore should come out as being 11.65 grams. Question 2 starts with a little bit of relative formula mass calculations, just checking can you use your calculator. Sodium nitrate, 23 plus 14 plus 3 16s is 85. Sulfuric acid, 1 plus 1 plus 32 plus 4 16s ends up being 98. Calcium hydroxide, 40 plus 16 plus 1 twice gives you a mass of 74. Now, we've got a tricky definition in part B. What's meant by 1 mole of substance? That's talking about the key relationship within what does a mole of something actually mean. What you have got in your notes is this little relationship here, which is what they're looking for. The relative formula mass of a substance in grams is the mole of it. So in other words, if I've got 12 grams of carbon, because carbon's relative formula mass is 12, 12 grams will be 1 mole of it. That's what that definition means, but you can just plonk it down and get the marks for it. Part C is another mole question. So it gives you this equation for iron oxide and carbon monoxide making iron plus carbon dioxide. Relative formula mass of the iron oxide is 160, gives me that to start with. How many moles are there? So moles equals mass over RFM. The mass is 80. It gives me the RFM is 160, so that fraction will give me 0.5 moles. Part 2, how many moles of iron could be produced from that amount of iron oxide? So I know it's 0.5 moles of it. If I've got 0.5 moles of this, I need to look at my ratio for iron oxide to iron. So it's gone off the page. Iron oxide to iron. So it's a 1:2 ratio between these two. So 0.5 moles of iron oxide will give me twice as many moles of iron. That gives me 1 mole. So it's 0.5 times 2 using a ratio. Part 3, calculate the maximum mass of iron that produced from 80 grams of iron oxide. It says you may need to use your dial leaflet. That means use your periodic table for the mass number. Mass equals moles times RFM. I've worked out in the previous part, I've got 1 mole of iron. The RFM of iron is just this mass number, which is 56. Not too hard, that's 56 grams of the product. We've got a very strange looking part 4 here. Calculate the maximum mass of iron that could be produced from 8 tons of iron oxide. 1 ton is 1,000 kilograms. Basically, well, it looks at first glance you have to do like a whole other mole calculation because it's a different mass here, but it's only 1 mark, so it mustn't involve that much calculation. What it basically wants you to work out is kind of a way to scale up or scale down from 80 grams of something to 8 tons of something. Essentially what you're having to use here is like a wee bit of kind of logic. 80 grams of iron oxide eventually led from my calculation to get me 56 grams of the iron. That will scale up and scale down. So if I, for example, this isn't the question, just like it'll get me towards it. If I only used 8 grams of iron oxide, that's a tenth of that. So it's going to be a tenth of the final mass, 5.6 grams of the iron. If I've got 8 tons of it though, I know it's obviously a lot more, but I was just scaling up. Sometimes I get by basically a million there to get to tons. That will just scale this up by the same amount. It's not going to be 5.6 grams, it's going to be 5.6 tons of Fe. Now, I personally think it's quite a difficult question to do, just like that, but it's basically using a wee bit of logic to go from 80 grams to 8 tons. Basically, you divide by 10 and change the units to get your answer there. Question 3. Again, very repetitive kind of style here. It's starting with a wee bit of work on relative atomic masses, or relative formula masses, sorry. First one they give you is ammonia, NH3, 14 plus 3 ones give you 17. Sodium carbonate, 2 23s plus a 12 plus 3 16s gives you 106. Magnesium hydroxide, a 24 plus a 16 plus 1 twice gives you 58. Again, you see that same question that was on the previous one. What do you understand by the term a mole of a substance? Mole of a substance is just this, like before. The relative formula mass of a substance in grams. That's the key relationship there. It then leads us on to kind of working out for a mole kind of question. This wee bit just on conversions. The relative formula mass of sulfur dioxide 64. What's the mass of 0.6 moles of it? So I have to use mass equals moles times RFM. It's just checking I know that relationship. It's therefore 0.6 moles times the RFM they gave me is 64. That gets me 38.4 grams. How many moles are there in 320 grams of sulfur dioxide? That's just going the other way around. So moles equals mass over RFM, which gives me 320 grams over 64, still the RFM, gives me 5 moles of sulfur dioxide. Part D, it's a mole question, reacting mass question. Solid silver chloride can be formed by this reaction. Gives you silver nitrate, magnesium chloride, silver chloride, magnesium nitrate. Saves me a wee bit of time by giving me all the relative formula masses. How many moles of magnesium chloride would be needed to react with 8.5 grams of silver nitrate? It's a 2-mark question, so getting me to do 2 steps basically in this part. First thing for me to work out is the number of moles in 8.5 grams of silver nitrate. That's generally where we start. So moles equals mass over RFM. 8.5 is the mass of silver nitrate. To give me the RFM is 170. Equals 0.05 moles. So that's the moles of silver nitrate. It wants the moles of magnesium chloride to react with that. What I basically have to look at is the ratio in the equation. 2 silver nitrates react with 1 mole of magnesium chloride. It's a 2-to-1 ratio. I have to divide by 2. 0.05 divided by 2 is 0.025 for that first part of the question. Part 2, it wants me to use that equation to calculate the mass of silver nitrate needed to produce 14.35 grams of silver nitrate. So I'm kind of having to work backwards a wee bit here. So it's given me 14.34 grams of silver chloride. So I need to work out the moles of it first. Mass over RFM. RFM of silver chloride is 143.5. That gives me quite a neat number, which is 0.1 moles of it. It wants me to work out the mass of silver nitrate needed for that. So I have to work backwards a wee bit. I've got 2 silver chlorides comes from 2 silver nitrates, therefore 1 would come from 1. It's just a 1-to-1 ratio, so therefore it's just the same number of moles of silver nitrate. Have to convert back into a mass. Mass equals moles times RFM, which equals 0.1 times by RFM of silver nitrate is 170, which gives me 170 grams for that answer. Question 4 then. Very familiar start. It's a 3-mark definition. What's meant by the relative atomic mass of an element? Same one we always have. Mass of an atom compared to the carbon-12 isotope, which is a mass of exactly 12. 3 marks for that. Part B. Calculate the relative formula mass of each substance given below. So again, just checking you're adding up. 2 23s plus a 32 plus 4 16s gives you 165. 127 plus a 16 plus a 1, so 17 times 3, gives you 78. Part C is a reacting mass question. Gives you an equation, gives you some relative formula masses. It's going to get you to work out some reacting masses together. How many moles of potassium iodide would be needed to react with 33.1 grams of lead nitrate? So first thing to start with is I've got 33.1 grams of lead nitrate. So moles first. Moles equals mass over RFM. Mass is 33.1. The RFM of lead nitrate gives me is 331. That gives me 0.1 moles. That's not quite the answer though. I've got the moles of lead nitrate. I want to work out the number of moles of potassium iodide that would react there. I need to use my ratio for that. It's a 1-to-2 ratio of lead nitrate to potassium iodide. Therefore, I multiply up by 2 to get to potassium iodide. So 1-to-2 ratio. So I need to multiply this by 2 to give me 0.2 moles of potassium iodide, which is the answer. Part 2. Different mole calculation. Calculate the maximum mass of lead iodide that could be obtained from 33.1 grams of lead nitrate. So the start of it is just the same. I've got 33.1 grams of lead nitrate. Therefore, the moles of lead nitrate I've worked out already from the previous part of the question is just 0.1. Need to use my ratio again. The maximum mass of lead iodide that could be obtained from that. So to do that, I need to use my ratio again. It is just a 1-to-1 ratio of lead nitrate to lead iodide. Therefore, it's going to be 0.1 moles of lead iodide. Need to work it back into mass. So I need mass equals moles times RFM. 0.1 times by the RFM of lead iodide, which is 461, which gives me an answer of 46.6 0.1 grams. I have to spot for that question. It does look like there's a wee mistake in the mark scheme for that question I spotted. It's 0.2 moles here times 461. That is a mistake. It should just be 0.1 1-to-1 ratio, which is what I've gone through there. Just be careful of that. Final bit, part 3. If a student used 0.2 moles of lead nitrate and 0.2 moles of potassium iodide in this equation, how many moles of lead iodide would be produced? Basically, that's kind of like a limiting reactant question, which is a little bit tricky. So I've got 2 different number of moles. I need to work out how much is going to go through to make the product. If I take the first bit, 0.2 moles of lead nitrate here, it reacts in a 1-to-2 ratio of lead iodide. Therefore, if I had 0.2 moles of this fully reacting, I would actually need 0.4 moles of potassium iodide to react with that because it's a 1-to-2 ratio. I need twice as much potassium iodide as I do lead nitrate. Therefore, if I've only got 0.2 moles of lead nitrate, 0.2 moles of potassium iodide, it's going to be holding my reaction back. It's going to be used up first, far before the lead nitrate's used up. Again, it's because 1-to-2 ratio, 0.2 moles of this will react with 0.4 moles of this, which I don't have. I only have 0.2. Therefore, it's the potassium iodide is going to determine how much product's going to be made because it's going to be used up first. I have to use it for the ratio. It's a 2-to-1 ratio of potassium iodide to lead iodide. Therefore, 0.2 moles of potassium iodide, which is what I've got, will go down to 0.1 mole of lead iodide. The answer is 0.1 moles.